Hi, Chem 20s. Mr. Riley here. I'm going to give you one more video on limiting and excess stoichiometry. And these questions, we are looking to calculate. We're given a chemical reaction, and we're looking to calculate the expected quantity of product. Now, I mean, this is kind of what we've been doing all along in stoichiometry. The only difference is for these questions is you're going to be given the amounts of two reactants. You're going to have to figure out which one is the limiting and then use that to determine how much product you can possibly produce. Okay, so let's look at this question. This is question number 1 from your workbook with my Chem 20s. So here's the question. It says, it gives us a following reaction for the formation of manganese 3 fluoride. It's a little bit of a weird chemical reaction, but that's okay. It says 1.24 grams of manganese 2 iodide. So that's this substance right here, 1.24 grams. Reacts with 25 grams of fluorine gas. What mass of manganese 3 fluoride is expected? And so we want to know the mass of this substance right here. Okay. So we need to determine out of my two reactants which one is limiting, and then we need to use that substance to determine the amount of product that we're going to expect in this chemical reaction. Okay, so let's start with our manganese 2 iodide. So I have 1.24 grams of MnI2. Okay, I am going to need to convert that to moles. Okay, so to find moles of my MnI2, I'm going to need my grams of MnI2, and this conversion factor is my molar mass. So I've already calculated my molar mass of this substance, and it's 308.74 grams for every 1 mole. Okay, so now at this point, I'm going to do this a little bit differently again as well. There's all sorts of ways to work your way around the math in these questions. I'm going to go right into determining how many moles of that product that I can produce. So using my molar ratio from my balanced chemical equation, I know that I can create in my balanced equation, 2 moles of MnF3 for every 2 moles of MnI2. Okay, so these are in a 1-to-1 ratio. So I'm going to do my math here. I'm going to take my 1.24 grams of MnI2. I'm going to divide that by 308.74. Okay, and I don't need to do the next step because I'm just going to be multiplying by 2 over 2. And so I'm going to get 0.0040 moles of MnF3. So what I'm saying here is if that 1.24 grams of MnI2 completely reacts, I can produce 0.0040 moles of MnF3. Okay, now let's see how much I could produce using my other reactant, my fluorine gas. So I have 25.0 grams of fluorine gas. Okay, I want to change that into moles, and so I need a molar mass here. My molar mass, it's 38 grams per mole. This time I have a little bit of a different ratio. For every 2 moles of MnF3, I'm going to need 13 moles of F2. Okay, so let's calculate this. So 25 divided by, so times 1 over 38. Times 2 over 1. And there's multiple ways to put this in your calculator too. Like you could do each step, press equals. You can use the divide symbol instead of me by multiplying by fractions. There's multiple different ways to do it. And so the answer that I get here is 1.31. Was it 1.3? So 1.32, it doesn't really matter because this is our excess. So what the information here is telling me is that if all of my magnesium iodide reacts, I can produce a maximum of 0.0040 moles of MnF3. If all of my 25 grams of F2 reacts, I can produce a maximum of 1.32 moles of MnF3. So the one that's smaller here is my limiting. Okay, so the amount of magnesium iodide, or sorry, excuse me, manganese 2 iodide that I have here, this is my limiting reagent. Okay, this is my excess reagent. Okay, and so using my limiting reagent, now I can go and figure out what my mass of manganese 3 fluoride expected is. So I don't really need the bottom part here anymore. Okay, I need to use this number. And so what I'm going to do with that is I'm now going to convert it to grams because the question's asking me for mass. So I need molar mass of MnF3 here. So I'm going to need to go and calculate that because I did not do that before. Okay, so manganese is a molar mass of, I just had it here. Sorry, you guys gotta wait a second. I'm not doing this video again. Manganese is a molar mass of 54.94 plus my 3 fluorides. Oops. Okay, so there's my MnF3, 111.94 grams for every mole. Okay, so I just need to multiply these two values now. So my 111.94 times my 0.0040. Okay, and so let's see what we get. All right, so I got 0.4476. And so I'm going to round this to 0.448 somewhere along the line, or maybe my answer is rounded incorrectly right here, this answer right here. Okay, or really what I should be doing is using the raw value for this number, but I cleared my calculator and I'm in the middle of making the video, so it's kind of hard to go back and do that. But you guys get the idea. So I'm going to use that number that we got, 0.448. MnF3. Okay, so those are sort of, you know, the toughest ones that we'll see in terms of limiting excess stoichiometry. We need to find the limiting reagent and then use that to complete your stoichiometric equation, finding the product that you're looking for. Okay, hopefully that helps. See you guys next time.